Today we'll be talking about a few basic ECG concepts as well as the electrical conductance in the heart. So the first question is, what is an ECG? It is a recording of the electrical activity in the heart over a given time period, most commonly 10 seconds. So it is the primary pacemaker in the heart and is a complex spindle-shaped structure that lies at the junction of our SVC and our right atrium. Physiologically, it spontaneously depolarizes faster than any other cardiac cell. Myocardial cells love to follow the leader, and the SA node is our leader. The rate of depolarization of the SA node is mediated by a number of things like autonomic tone, stretch, temperature, hypoxia, blood pH, and also hormonal influences. Impulses travel from our SA node via these internodal fibers to our AV node and also via Bachmann's bundle and allow for atrial depolarization, and this is represented on an ECG as our P wave, right? Impulses are then delayed at our AV node. Now, AV node is my favorite node because this dude has a very important function, and that is to delay impulses from your atria to your ventricles, and this allows for ventricular filling in order to have sufficient blood volume prior to ventricular contraction, and this delay is represented on the ECG as our PR segment. It also serves to protect our ventricles from atrial tachycardias, as it delays some of the impulses that come through and also filters them so that only a certain number of them get through to the ventricles. The AV node is essentially the protector of the ventricle. The AV node is also the only pathway through which impulses can be conducted to the ventricle through what we call our annulus fibrosus, which I've drawn in green here. This is essentially an electrical insulator which prevents impulses from jumping across from our atria to our ventricles, meaning that the only pathway through is via our AV node. Right? Impulses travel from the AV node to the bundle of His, which we see over here, and then split into our right and left bundles, this is the right bundle and our left bundle. The right bundle continues down the right side of our interventricular septum and then gets to the apex of the heart, where it splits into Purkinje fibers. Right? The left bundle splits into our anterior hemibundle and our posterior hemibundle. The anterior hemibundle supplies the anterior and superior subendocardial Purkinje fibers, which are these over here, and the posterior hemibundle supplies the inferior and posterior subendocardial Purkinje fibers. The sum total of all of this is to produce what we call our specialized conduction tissue in the heart, which is essentially a highway of electrical conduction, which allows myocytes to depolarize at the same time producing narrow Curies complexes, right? And two, from the apex to the base of the heart, so that blood can be ejected in a coordinated fashion, so that it can be ejected from the right ventricle to the lungs and from the left ventricle to the body. The total of all of these depolarization produces what we know as our Curies complex, which represents ventricular depolarization. Now you may be thinking, where is our atrial repolarization? And this is not normally seen in an ECG, as it's masked by the electrical activity of ventricular depolarization. Cardiac myocytes are special in that they have a refractory period after depolarization, and this is represented by our ST segment. This is essentially the flat isoelectric section between what we call our J point, which is this point over here. Let me erase these, which is this point over here, and our T wave. The T wave on the ECG represents our ventricular repolarization. And finally, the QT interval is from the start of the Q wave, right, to the end of the T wave, and represents both ventricular depolarization, delay, and repolarization. Final thing that I just wanted to chat to you guys about is, what is a Q wave, right? A Q wave is a negative deflection without a preceding positive deflection. What is an S wave? An S wave is a negative deflection with a preceding positive deflection. And what is an R wave? An R wave is any positive deflection.